Now my next question, that is fifth number question. Two charges of 50 microcoulomb and 100 microcoulomb are placed at a distance of 0.06 meter apart. Find the charge and potential at points between the two charges and 0.02 meter from the charge of 50 microcoulomb. Here again I will repeat that question. Two charges of 50 microcoulomb and 100 microcoulomb. Here another question. So two charges, that is 50 microcoulomb, fifth number question, and this is 100 microcoulomb. 50 microcoulomb, 100 microcoulomb charges are placed at a distance 0.06. So the distance between them is 0.06 meter apart. Find the charge and potential at a point between the two charges. If you represent a point, here we represent a point. At that point we have placed a test charge, and now we have to calculate the magnitude of that charge and electric potential at that point, where the distance from the first charge, that is 50 microcoulomb, is given by what? 0.02 meter. Okay, so here again I repeat that question. Two charges of 50 microcoulomb and 100 microcoulomb are placed at a distance of 0.06 meter apart. So this is 50 microcoulomb and this is the 100 microcoulomb charge. Both are same in nature and they are having distance 0.06 meter. Find the charge and the potential at point P between the two charges. If you represent a point P, that is point P, here that point we have to calculate the magnitude of test charge and also calculate electric potential at that point. And that point P, which is situated at distance 0.02 meter from the 50 microcoulomb charge, which is represented in that question. Okay, so if the test charge which is present, that test charge is a unit positive charge, that positive charge, unit positive charge, exert a force of repulsion due to 50 microcoulomb. So the force which is radial outward and that is along in that way, it is F1. Due to 100 microcoulomb test charge which also exert a force of repulsion, the force of repulsion due to test charge, the test charge moving in that way, that is F2. Okay, now I will find out the magnitude of test charge according to Coulomb's law of repulsion. So this is the force F1, that's why electric field intensity is also along in that direction. That is force F2, that's why electric field intensity along in that direction. So first of all we have to calculate electric field intensity at that point P, net electric field intensity due to 50 microcoulomb and due to 100 microcoulomb. Okay, so first of all we have to calculate electric field intensity due to 50 microcoulomb. So E1 is given by 1 by 4 pi epsilon 0 here Q by R square. So that you can represent as 1 by 4 pi epsilon 0 means 9 into 10 to the power 9. Q means what? Q means 50 microcoulomb. 50 into 10 to the power minus 6 coulomb divided by R means what? The point P which is situated at a distance 0.02 meter from the 50 microcoulomb. So that means 0.02. Okay, so 9 into 10 to the power 9 into 10 to the power minus 6 into 50 divided by 2 into 10 to the power minus 2. So here you write 9 into 10 to the power 9, 10 to the power minus 6 can be represented 10 to the power 3 into 50 divided by 2. 10 to the power minus 2, which is represented in denominator, now it can be represented in numerator, so it can be represented as 10 to the power 2. So here you write 9 into 50 divided by 2 into 10 to the power 5. So 250 cancel out, so that can represent 25 into 9 into 10 to the power 5. That means 225 into 10 to the power 5 Newton per Coulomb. That is, electric field intensity is given by it is r square, that can be represented as square is there, so that is also square. So here you write 10 to the power minus 2 and 10 to the power minus 2, that can be 10 to the power 2 into 10 to the power 2, that is 10 to the power 4, because 10 to the power minus 2 power is 10 to the power minus 2 power is 10 to the power minus 4, and 2 square is 4. So here you write 2 into 2. So here in that case 2 into 2 is here, that is why into 10 to the power 2 is represented as, and also 10 to the power 2 is there. So here we compute, divided by 2 is here, so 25 to 5 by 2 into 10 to the power 7 Newton per Coulomb. It is E1. Similarly, E2, electric field intensity due to electric field intensity at point P due to 100 microcoulomb, that is E2 equal to 1 by 4 pi epsilon 0 Q by R square. So 1 by 4 pi epsilon 0 means 9 into 10 to the power 9. Charge means 100 microcoulomb, that means 100 into 10 to the power minus 6 divided by R square. Here, from above diagram, this is the distance between point P to 50 microcoulomb is 0.02 meter, and total distance between two charges is 0.06 meter. Therefore, the distance between point P to 100 microcoulomb is 0.04 meter. So here R can be represented as 0.04 meter square. So here we write 9 into 10 to the power 9 into 10 to the power minus 4 divided by 4 into 10 to the power minus 2 whole square. That means 9 into 10 to the power 9 into 10 to the power minus 4 here 10 to the power plus 4 divided by 16, because 4 means 4 square means 16, 10 to the power minus 2 into 10 to the power minus 2, that is 10 to the power minus 4, so it can be represented in numerator, 10 to the power 4 is there. So 10 to the power minus 4, 10 to the power minus 4 is cancelled out, so 9 into 10 to the power 9 by 16, that is E2. Therefore, net electric field intensity, that is Newton per Coulomb. Net electric field intensity is given by, so due to positive charge 50 microcoulomb, electric field intensity is along outward, and due to 100 microcoulomb, electric field intensity is also outward. So both are in opposite direction. Net electric field intensity at that point P is given by P equal to E1 minus E2. Why it is E1 minus E2? Because the test charge, which is nearly from the 50 microcoulomb. That's why there is a huge electric field intensity produced at point P due to 50 microcoulomb. So that is, the magnitude of electric field intensity is more at that point as compared to 100 microcoulomb, because 100 microcoulomb, which is situated at far away from the point P. That's why we have to represent E1 minus E2. So here we write electric field intensity, which is equal to E1 minus E2. So E1 means what? That is 225 divided by 2. 225 divided by 2 into 10 to the power 7 minus into means what? 9 into 10 to the power 9. 9 into 10 to the power 9 divided by system, which is given by, if we represent 225 into 10 to the power 9 divided by 200, because multiplying 100 in both numerator and denominator, so it can be represented 10 to the power 9 divided by 200 minus 9 into 10 to the power 9 divided by 16. So in that case, both of the cases 10 to the power 9 is 0, 10 to the power 9 is so taken on outside. Taken in outside, 10 to the power 9 is taken in outside. So you will write 225 divided by 200 minus 9 by 16 is 0. So in that case, 10 to the power 9. So you will write 25 this 25 25 200 minus 9 by 16. So again 9 is taken in common. So 9 into 10 to the power 9. 1 by 8 is here, 1 by 16 is here. 9 into 10 to the power 9 into if you represent in LCM, so it can be represented as 16. So 2 minus 1, so that means 1 by 16 into 9 into 10 to the power 9. That's why 9 by 16 into 10 to the power 9. So 9 by 16 is 0.56 into 10 to the power 9. That means 5.6 into 10 to the power 860. Okay. So it is electric field intensity, Newton per coulomb. In the direction of electric field intensity, which is along 100 microcoulomb. Therefore, direction of electric field intensity is along 100 microcoulomb. Okay, because the point P, which is very nearer to that 50 microcoulomb, so that's why it produces huge amount of electric field intensity. So the magnitude of electric field intensity is given by 5.6 10 to the power 8 Newton per coulomb, and the direction of electric field intensity, which is moving towards the 100 microcoulomb, because the 100 microcoulomb, which is far away from the electric field intensity, 100 microcoulomb, which is far away from the point P. That's why, so it produces a less amount of electric field intensity. Therefore, if you represent a net electric field intensity, then we represent E1 minus E2. Therefore, electric field intensity whose direction moves along 100 microcoulomb, that is towards the 100 microcoulomb, or you will write towards the 100 microcoulomb. Okay. Now we have to calculate electric potential. Here, electric potential at point P due to both of the charges. So that electric potential due to both of charges are added algebraically, because electric potential is a scalar quantity. So net electric potential at point P due to both 50 microcoulomb and 100 microcoulomb is given by P equal to 1 by 4 pi epsilon 0, that is QA by distance, that is PA. If you represent in the diagram, this is point A and this is point B. So the distance between them is P. So QA by PA plus 1 by 4 pi epsilon 0 QB by PB. That means if you represent 1 by 4 pi epsilon 0 taken in common, QA means what? That means 50 by PA distance is 0.02 meter. 0.02 meter plus QB means 100 microcoulomb. Micro means 10 to the power minus 6 is here and 10 to the power minus 6 is here, divided by PB means PB distance is 0.04. So 0.04. So 1 by 4 means 9 into 10 to the power 9. 10 to the power into 10 to the power minus 6 taken in common, divided by into 50 by 2 into 10 to the power minus 2 plus 100 into 10 to the power 100 divided by 4 into 10 to the power minus 2. So 9 into 10 to the power 9 into 10 to the power minus 6 here, 50 into 10 to the power 2 by 2 plus 100 into 10 to the power 2 divided by 4. So you write 9 into 10 to the power 9 into 10 to the power minus 6 into 10 to the power 2 taken in common, 50 by 2 plus 100 by 4. So 9 into 10 to the power 11, 10 to the power 5, because 11 minus 6, that is 5, into 50 by 2, that is 25, into plus 25, 100 by 4 is 25. So 50. So 50 into 9 into 10 to the power 5, that implies 450 10 to the power 5 volts. Electric potential at point P due to both 50 microcoulomb and 100 microcoulomb is 450 into 10 to the power 5 volts. Or if you represent V equal to 4.5 into 10 to the power 7 volts at that point P. Here electric potential at point P due to 50 microcoulomb and 100 microcoulomb is 4.5 into 10 to the power 7 volts. Okay, this is question number 5. Now 6 number question. Here here 2 point charges each of 3 into 10 to the power minus coulomb are located at the two vertices of an equilateral triangle of side 0.20 meter. How much work must be done to bring a charge of 10 to the power minus 19 coulomb up to third corner of the triangle from infinite? Here again I will represent that question. 2 point charges. So this is the 2 point charges, that is 3 into 10 to the power minus 9 coulomb, 3 into 10 to the power minus 9 coulomb at point A and B of the two vertices of an equilateral triangle. That means this is the equilateral triangle. Okay, that is at two vertices, two charges are placed having magnitudes 3 into 10 to the power minus 9 and 3 into 10 to the power minus 9. And the sides of sides kete, these are the sides, this is the side, this is the side, this is the side. So 0.20 meter, 20 meter, 0.20 meter. How much work must be done to bring a charge of 10 to power minus 19 coulomb up to third corner of the triangle from infinity. যদি গোটে ইনফিନିটি গোটে টেस्ट চার্জ को नबा सी पॉइंट को आनिबा सेते बेले तार वर्क डन केते जनरेट हबो. ओके सो प्रथमे हम कोन करिबा इलेक्ट्रिक पोटेंशियल काढिबा at point C due to both point A and point B. Here the charges are placed at point A and point B is given by 3 into 10 to power minus 9 coulomb. So now to calculate electric potential at that point C due to both point A and both point B of an triangle. So electric potential here we write in 6 number question. Let us suppose QA and QB are placed at a corner A and B of an equilateral triangle. Of side 0.02 meter. Sorry, side 0.20 meter. Clear? Now we have to calculate potential at point C due to point A and B. Therefore, electric potential at point C is given by 1 by 4 pi epsilon 0 QA divided by AC plus 1 by 4 pi epsilon 0 QB divided by DC. Because electric potential at point C due to charge which is placed at A due to charge which is placed at B. So they are added algebraically because the electric potential is a scalar quantity. So DC which is equal to 1 by 4 pi epsilon 0 taken common. So QA by AC plus QB by DC. So 1 by 4 pi epsilon 0 is 0, that is 9 into 10 to the power 9. QA means 3 into 10 to the power minus 9 by AC means what? 0.20 plus QB means 3 into 10 to the power minus 9 divided by 0.20. That means 9 into 10 to the power 9 is taken into here. If you taking LCM, that is 0.2. 0 means negligible, so it is 0.2. So here we write 3 into 10 to the power minus 9 plus 3 into 10 to the power minus 9. 9 into 10 to the power 9 into 10 to the power minus 9, that is 6 by 0.2. So 10 to the power 9, 10 to the power 9 cancel out. So here you write 54 divided by 0.2. Difference 54 540 by 2. That means what? It is 270 volts. That is VC. VC equal to what? 270 volts. Now electric potential already I calculated this way. See, according to question, how much work must be done to bring a charge of 10 to the power minus 19 coulomb up to third corner of the triangle from infinity? We have to calculate work done at point C while the charge having 10 to the power minus 19 coulomb, which is bringing from infinite to that point P. Therefore, work done is given by work done to bring a charge of 10 to the power minus 9 coulomb from infinite or infinity to point C. That is W equal to VQ. That means we know V equal to W by Q, that means W equal to VQ. V means what? 270 into Q means 10 to the power minus 9. That means what? Work done equal to 2.7 into 10 to the power minus 7 Joule. So this is the work done while the test charge of 10 to the power minus 19 coulomb from infinite to the corner of point C. That is about 2.2 10 to the power. That is about W equal to 2.7 into 10 to the power minus 7 Joule. Thank you.